time to talk about angular and linear speeds. And I hope that you've noticed in my video content that I like to keep things really, really simple. So let's discuss this central angle theta in a circle of radius r. And we've already talked about arc length s and whatnot. But what happens if I make one full rotation of the circle? Meaning if I start at a point P and I rotate the circle, turn it all the way around, go all the way back to P, that forms an angle of 360 degrees or 2 pi radians. And it travels a linear distance equivalent to the circumference of the circle. Now think about that for a minute. Okay, if I were to roll this guy out on the ground or put a tape measure around the circle, then to start at P, roll it out and get all the way back out to P is the distance around the circle. Okay, and the units of measure will depend upon how r is measured: inches, feet, miles, meters, centimeters, so forth. Okay, so this is the basic premise that I want you to hold on to. Angular speed is a measure of how fast a wheel, or a circle if you will, is rotating with regard to its angular measure per time. So that's like saying 360 degrees or 2 pi radians per minute or per second, something like that. Whereas linear speed is a measure of how fast I travel the distance around the circle. So it's distance per time. Okay, and that distance sometimes could be not the entire distance around the circle, but simply a portion of the circle's full distance or arc length. Okay, let's look at an example. Okay, so here's an example where we're given that a wheel of radius 7 inches is rotating 2100 RPMs. RPMs stand for revolutions per minute. Now let's think about this. Revolution means go all the way around. That's the same idea as rotations. Okay, so it's 2100 full rotations in 1 minute. Now we know that if you rotate or revolve one full time around the wheel, then you actually form a central angle of measure 2 pi radians. So again, if we took this and we went all the way back around, okay, that's 360 degrees or 2 pi radians. So there are 2 pi radians for one full revolution if we look at an angular measure. So now our units cancel here and here, and we would just simply naturally be left with 2100 times 2 pi, and our units just naturally fall as radians per minute. This is angular speed because we measured the angle the wheel rotates through in 1 minute. Okay, and if you got the calc pad, you don't even have to simplify. Notice you don't have to put the units in, they're already typed out for you. Okay, so that's part A. Now part B is linear speed. So again, using the premise that I told you earlier, if I make one full rotation or one full revolution, then that's going to be equivalent to traveling 2 pi times the radius, or the circumference of the circle, and this would be in inches because r is in inches. So one full revolution, and we travel a total of 14 pi inches, and this is around the circle. Okay, so the circumference is 14 pi inches. All right, now bear with me here. We want linear speed, but see, we know that the rotations were being made in revolutions per minute, so we know that the time is in minutes. Okay, now let's go back to what we said a minute ago. Oh, no pun intended. 2100 revolutions per minute means that if I make one revolution, I travel 14 pi inches. Okay, now my units are down to inches per minute, which is fine. That's linear speed. But the question asks you to go one step further and write this in feet per minute. So now we would want inches to cancel. We want to be left with feet. We're going to keep our minutes, and we know that there are 12 inches in 1 foot. Now our inches cancel, and our total calculation is 2100. Multiply all of our numerators together. Divide by the product of all the denominators, and this one had an understood 1. And our units that are left standing are feet per minute, which is what we were asked to give. Okay? So, yes, angular speed and linear speed are intrinsically related because one revolution is equivalent to the angle 2 pi radians and is also equivalent to traveling around the circle the length of the circumference.